Welcome dear students. In previous lecture we learned about the real numbers and we completed practice set 2.1 and 2.2. Now today's our topic is surds. In today's lecture we have to learn what is surds and various processes on a surds. Like that we have to write the surds in a simple form. Then what are the like surds, unlike surds, then order relation between the surds. Such basic concept about the surds we have to learn today. In standard 8 we learn about the indices. Suppose I write here 5 raised to 2. Here 5 is the base and the index of this 5 is 2. Therefore we read it as a 5 square. Suppose I write here 6 raised to 3. That means 6 cube. Like this this called as a base and this is the index. Now there is another method. Suppose I write here 5 raised to 1 upon 2. Here difference is, here index is a 2 and here it is index is 1 upon 2. Now dear student, we read it as a square of 5 and here we read it as a square root of 5, that is second root of 5. Suppose I write here 6 raised to 1 upon 3. Then here 6 is the base and index is 1 upon 3. Therefore we write here third root of 6. It is the third root of 6. I write here 25 raised to 1 upon 2. 25 raised to 1 upon 2 means we write here square root of 25. By using the symbol we can write 25 square root of 25. Suppose I write here 6 raised to 1 upon 3. Here we got the answer, that is 6 raised to 1 upon 3. That means it is the cube root of 6. Now cube root or the third root of 6. Then we write here cube root of 6 like this, 6 here, and here it is we have to write the 3. This is by index form and this is we are writing by the symbol. Now dear student, this is, we can find out the answer of this, that is the square root of 25, it is 5. Here cube root of 6, we can't find out the cube root of 6. That means here this number is a rational number, that is cube root of 25 is the rational number. Here this cube root of 6, square root of 25, answer we got here 5, therefore this is the rational number, and here this is called as an irrational number. Suppose I write here 27 raised to 1 upon 3. Then by using symbol we can write here 27 and here we have to write the 3. That is we can read it as a cube root of 27, and dear student, cube root of 27 we can find out it is 3. Therefore it is a rational number. Now dear student, all of you understand, this is the index form. We write it by using the symbol square root of 25 and it is 5. It is the cube root of 6 raised to 1 upon 3. That means it is the cube root of 6 and cube root of 6 is an irrational number. Here we write 27 raised to 1 upon 3. That means it is cube root of 27. We read it as a third root of 27 and therefore we get the answer as a 3 and 3 is a rational number. This is the basic. I want to tell you that what is the surds. For understanding this surds you must know this the basic things, and therefore here 25 raised to 1 upon 2 means square root of 25. Here answer is a 5 and this 5 is a rational number, that means root 25 is a rational number. Here 6 raised to 1 upon 3, that means cube root of 6 and cube root of 6 is an irrational number. 27 raised to 1 upon 3, that is cube root of 27, it is 3, therefore it is rational number. Now dear students, suppose I write here square root of 81. Can anyone tell me square root of 81 is a irrational or the rational number? It is a rational number because we can find out the square root of 81, and square root of 81 is a 9, therefore it is a rational number. Now see dear student, suppose I write here this a, here it is n, that means now you can understand this, it is the nth root of a. We can read it as the nth root of a. We read it as a square root of 25, third root of 6, it is the third root of 27, same, it is the n root of a. Now in this case, suppose we write here n is an integer greater than 1. First condition is n is an integer but it is greater than 1. Integer for positive integers, negative integers and 0. We required here that n must be a integer but it is a greater than 1. This is the first condition. Then this a is a positive real number, and this nth root of a is irrational number. Then the number which is written in this form is called as a surds. Now I think you got the clues here. Nth root of a. In this case, this n is an integer but that integer is greater than 1. Second condition, this a must be a positive real number and this whole number is an irrational number if the number which is written in the form of this follows these three properties. Then we say that this is called as a surds. Now see here, I write here 25 raised to 1 upon 2, that is square root of 25. Square root of 25, that means here the number denoted by this n is a 2. Now n is equal to 2 and this n is equal to 2 is a positive integer greater than 1. That is the first condition is fulfilled. Then second condition, this a means here it is 25. This 25 is a positive real number. Yes, the second condition is also get fulfilled. Now the third condition is that number should be irrational number. Now see here, square root of 25 is a 5 and square root of 25 is a 5, that pi is a rational number. That means this third condition is not followed, therefore the number 25 raised to 1 upon 2 or square root of 25 is not a surds. Now see the second sum. Here I write 6 raised to 1 upon 3, that means it is a cube root of 6, and cube root of 6, first condition, the number denoted by n is a 3 and 3 is an integer greater than 1. This 6 is a positive real number. Yes, perfect. And can we find out the cube root of 6? No, therefore it is a irrational number and therefore all these three conditions are followed. Therefore we say that this is a surds. Therefore this is a surds. I take the another example. Suppose I write here 26. Now square root of 26. Now in this case, here the number denoted by n is not written over here. That means it is a 2. Therefore n is equal to 2. It is a integer greater than 1. Second condition is that this a is equal to 26. This 26 is a positive real number. Yes, it is a positive real number. And can we find out the square root of 26? No. Therefore it is that means square root of 27 is a irrational number and therefore this is a search. I think everyone understood this. I take the another example. Suppose I write here 8. Now see here 8. This is a, here there is a no number, that means the number denoted by n is a 2. Yes, n is equal to 2. Then a is equal to 8, and tell me the square root of 8. Square root of 8 is irrational number, therefore this is a search. Now see the second. Same, I write here 8 and here I write 3. Now n is equal to 3. It is a integer greater than 1. Second, 8 is a positive real number, and cube root of this 8. Dear student, can we find out the cube root of 8? Yes, it is equal to 2. Now tell me, this 2 is a rational number or irrational number? It is rational number, and therefore third condition is not followed, therefore this is not a search. Square root of 8 is a search, but the cube root of 8 is not a search. Got it? Therefore this is the basic of the search. Now see here, we have to see the another concept about the search. Now everyone understood, if any number is a given and if we have to decide whether it is a search or not, first of all we have to see the root. The number denoted by root is a integer greater than 1. Second condition is a positive real number, and nth root of a is an irrational number, then it is called as a search. There are some words or some concepts related with the search that we have to learn now. See here, I write nth root of a. Now nth root of a, in this case, this, first of all we have to see this sign. This sign is called as a radical sign. Then n is called as a order of search, and third one is a is called as a radicand. These three concepts or the three concepts related with the search you must know. This symbol is known as a radical. Then this number denoted by this n is called as the order of the search, and a is called as a radicand. Now see here, one example is, it is square root of 26. Now the number denoted by this n is not there, that means it is 2. Therefore in this case, if we write the order of this set, then order of this set is a 2. Here, then this a denoted by 26, therefore this 26 is called as a radicand of the set. Radicand. Now see here, if we consider this is a set, because cube root of 6 is an irrational number. Cube root of 6 is an irrational number, therefore this is a set. Now tell me the order of the set. Order of the set is a 3, radicand is a 3, and this is called as a radical sign. Now I think everyone understood this. This is the basic. In exam there will be a question, search. We have to define whether the given number is a search or not. Second question, find out the order of the search. When the order of the search is given, then we can write it easily. Now see, another concept we have to learn. First of all, here order of the search. Suppose I write here 26, order is 2. Here I write 24 and here it is 3. Then tell me the order. Order is 3. Suppose I write here 6, it is 4. then order is 4. Now depending upon the order of the surds are divided into many parts. Suppose order is a 2, then that surds are called as a quadratic surds. Students, order is 2, then it is called as a quadratic surds. In this chapter, we have to learn only the quadratic surds. That means order of every surds will be a 2. But in an exam, the question is there to find out the order of the surds. At that time, it may be another type of a surds. It may be a quadratic, it may be a cubic, or it is biquadratic. Suppose here, see, order is 3. Then it is called as a cubic surds. Order is 3. Then it is biquadratic when order is 4. When the order is 2, then it is called as a quadratic surds. When the order is 3, then it is called as a cubic surds. And when the order is 4, then it is called as a biquadratic surd. In this year, we have to learn only the quadratic surds. But in an exam, for finding out the order of the surds, there may be a cubic surd, there may be a biquadratic surds. Now I think everyone understood the basic concept of the surds. What is the surds? For that purpose, we have to follow 3 conditions. Integers greater than 1, it is positive real number, and the third one, it may be a irrational number. We have to see the another topic. Yes student, now we have to learn the simple form of the surds, or the simplest form of the surds. Suppose I write here one surd 48, and second one is a root 98. Now these are the two surds. Can anyone tell me what is the order of the surd? Order of the surd is a 2. Radicand is 48. Here order of the surd is a 2. Radicand is 98. Now we have to simplify this, or we have to write the simple form of the surds. Simple form of the surds. For that purpose, we have to factorize the radicand. All of you know that this year we have to learn the quadratic surds. That means order of the surd is 2. Here it is order 2. Now we have to factorize this 48. For factorizations, we have to find out the factors of this 48. And for that purpose, out of that 2 factors, one factor must be a perfect square. Why it is perfect square? Because order of the surd is a 2. Now dear student, you know that suppose I have to factorize this 48, then it is 24 into 2. Got it? 24 into 2. In this case, 2 is not a perfect square, 24 is also not a perfect square. Then we have to take the another, it is 16 threes. Then 16 threes is a 48. Then we can factorize this 16. 16 is a perfect square. Got it? Therefore we can write here 16 into 3. Now we write it separately like this, root 16 into root 3. Then square root of 16, it is 4, and here it is root 3. Dear student, this is called as a simplest form. Root 48 and 4 root 3 is a same surds. Now here 4 root 3. Here order is 2, radicand is 3, and one factor is a 4. Now see the another example. Now see 98. 98 we have to, first of all we have to see the order. Order is 98, and order is a 2, radicand is 98. Now we have to factorize this 98. One factor should be perfect square. It is 49 into 2. Now write it like this, into root 2, square root of 49, it is 7 root 2. these are the simplest form. We can factorize these 3, we can't factorize these 3, therefore root 98 is simplest form of root 98 is 7 root 2, and the simplest form of 48 is 4 root 3. We have to factorize this, whose perfect square should be there, and like this we can factorize we can write the simplest form. Suppose I write here root 50. For root 50, how can we factorize this? It is order is 2, radicand is 50, that 50 we have to simplify, it is 25 into 2. Now square root of 25, why we are taking square root? Because order is 2. Here it is 25 into root 2, then it is 5 root 2, radicand is 2, order is 2, and this is the another factor is 5. I think everyone understood this. Now we have to learn about the like surd or the similar surds. Like surd or the similar surd, this is the another topic. We can write here like or similar surds. Now dear student, suppose this is a 4 root 3 is a one surd, and second is a 5 root 2. Now if we have to decide whether these two surds are similar or not, then what we have to see? We have to see the order of the surds. Here order is 2. In this case order is 2. Then what is radicand? Radicand is equal to 3, and here radicand is 2. Then we are considering two surds, whether they are like or similar surd. For that purpose we have to see the order of the surds. If the order is same as well as radicand is also same, then the surds are called as a like surds. Suppose here radicand, suppose I write here 4 root 2 and 5 root 2. Here order of both the surd is 2. Radicand is also 2. Therefore these two surds are called as like surds. Got it? That means if we have to decide whether the given surds are like surds or the similar surd, for that purpose we have to see the order. Order must be same as well as the radicand are same. Then in this case order is 2, radicand is 2. It may be like this. Here 4 root 3 and 5 root 3. Here order is 3. Order is 2 and radicand is 3. Radicand is same, order is same, therefore these are called as a like surds. Here also order is 2 and radicand is 2, therefore it is also like surds. Here order is 2 and radicand is 3, therefore order is same, radicand are same, therefore it is a like surds. Now see, suppose I take another example. Root 45 and root 80. We have to decide whether given two surds are similar surds or the like surds. We have to decide. For that purpose, first of all, we have to observe the order. Order of this surd is 2, as first condition is follow. Second condition, we have to see the radicand. Radicand is not same. If we observe these two surds, order is not same. Order is same, but the radicand are not same. That means these are the not a like surds. But if we have to simplify this, then what will be happen? See, we have to simplify this 45. Now tell me the factors of 45. Order is 2, therefore perfect square should be there, and the factors are 9 into 5. 9 5 is 45, 9 is a perfect square, therefore root 9 into root 5, and root 9 is a 3 root 5. Square root of 9 is a 3 and square root of 5 is as it is. This is the simple form. This is the simple form of root 45. Now we have to see the root 80. Tell me the factors of root 80. Order is 2. It is 16 5. Now you understand, square root of 16 into square root of 5. Now square root of 16 it is 4 and here it is root 5. Now see dear student, 4 root 5. This is the simple form of root 80. 3 root 5 is a simple form of root 45. Now see, compare this simple form. Order is 2. Here it is order is 2. Radicand is 5. Here radicand is 5. That means both surds have the same order and both surds have the same radicand. Therefore these are the like surds or the simples, like surds or the similar surds. Therefore if we have to decide whether the given surds are simple or given surds are like surds or the simple surds, first of all we have to write it in a simple form, simplest form. After writing the simplest form, we have to compare that, and if order are same, radicands are same, then the surds are called as a like surds or the similar surds. That means writing the surds in a simplest form is most important thing. Let's see the new topic, that is comparison of the two surds. Two surds are given and we have to decide which one is a greater than 1 and which one is a smaller. For that purpose we have to see the order of the surds. If order of the surd is same, then we have to see the radicand. That means suppose here root A and root B, these are the two surds are given, and if we have to compare these two surds, then we have to see the order. In this case order is 2, here also the order is 2. Then we have to see the radicand. Here radicand A is there and here B is there. First condition, if A is greater than B, then square root of A is greater than square root of B. Second condition, if A is less than B, then we can say that root A is less than root B. And third possibility is if A is equal to B, then dear student, order is same, radicand is same, then the surds are called as a like surd. Therefore we can say that if A is equal to B, then root A is equal to root B. That means when we have to compare the two given surds, for that purpose we must know the order of the surds. Order must be equal, must be the same, then and only then we can compare the two surds. If the order is same, then we have to see the radicand. Radicand, depending upon the radicand, we can find out the comparison. Here A is greater than B, then root A is greater than root B. Here A is less than B, then root A is less than root B. And if radicand are same, then both the surds are same surds. Therefore these three possibilities will be there. Therefore dear student, if we have to convert the given surd into simplest form, if we have to find out the like surds or the similar surd, we have to see the order. That means for each process or each condition we have to see the order of the surds. If order is the same, in this case, if the order is same, then we have to see the radicand, and depending upon the radicand, we can say which set is the greater one and which is the smaller. I will take here one example, 6 root 2, and second one is 5 root 5. If we have to compare these two sets, then see here, this is the simplest form of the sets. First of all, we have to see the order. Here order is 2 and here it is also order is 2. That means both the sets have the same order. Now see here, we have to see the radicand. For that purpose, now in such type of a example, what we have to do, we have to take out this 6 root 2. This 6 we have to take in under radical sign. Now see this 6 we have to write under radical sign. For writing under radical sign, we have to see the order. Order is a 2, therefore we have to make the square of this. Therefore this 6 we write under radical sign as a 6 square into this 2. Now see here, square of 6 is 36 into 2, and 36 into 2, dear student, it is 72. Now this 6 root 2 and root 72, these are the same. Now we have to see the 5 root 5. Now this 5 root 5 we can convert, order is 2. This 5 we have to write under radical sign, therefore it is 5 square into 5. Now see here, square of 5 is 25 into this 5, then it is 125, root 125. Now we have to compare this, root 72 and root 125, we have to compare this. For that comparison, tell me which one is a greater one. Root 125 is a greater one. Therefore we can say that under root 72 is less than under root 125. But root 72 means 6 root 2 is less than 5 root 5. I think everyone understood this part of comparison of the two sets. We must have to see the order must be same, and then after we have to compare the radicand. If it is like this simple form, then we have to convert it into like this, and then we have to compare the sets. Dear student, we have to see the next topic, that is rationalization of sets. Now in this topic, see, suppose I write here root 3 into root 3. If I do the multiplication of these two sets, I will get here root 9 and the final answer is 3. This is a third, this is also a third, and if we multiply, that means we find out the product of two sets, and the product of the two sets is a rational number. Therefore these two sets are called as a rationalizing factor of each other. Suppose I write here 5 into root 5, then the root 25, and here it is 5. This is a set, this is a set. If we multiply the two sets, then we get the product is a rational number, then they are called as a rationalizing factor of each other. Suppose I take the another example which is given in a book, that is root 2. Suppose I write here root 2 into root 2. Now here it is very easy, it is 4 and here it is 2. That means if I make the product of these two sets, and the product of these two sets is a rational number, then these are called a rationalizing factor. But suppose I write here root 2 into root 8. Now dear student, if I multiply these two, we will get here root 16 and it is 4. That means this is also a rational number, and therefore if I take out this root 2 multiplied with this root 2, I get the rational number. This root 2 I multiplied with root 8, then also I get the rational number. That means this rationalizing factor is not a unique number. It may be a different. For this we can find out the another number. Suppose root 3 into root 3 I get here 9. Another number we multiply rational number, then also we get here the rational number. That means in this case root 2 into root 2, these are the rationalizing factor. For this root 2 not only the root 2 is the rationalizing factor, root 8 is also a rationalizing factor. Therefore we can say that the rationalizing factor is not a unique number. It may be a more than 1 or more than 2, like this. Here root 2 into root 2 it is 2, root 2 into root 8 we will get a root 16, and root 16 is equal to 4. Therefore we get the rational number. Therefore when we multiply two surds and we get the product as a rational number, then that two numbers are, or the two surds are called as a rationalizing factor of each other. Dear student, this is the basic part of the surds. Based upon this, there is a practice set 2.3. That practice set 2.3 we will see in the next video. Before that, you have to write all these things which is given in a book. See on a page number 26, there is a definition about the surds. That definition you have to write it in your notebook. Second, simple form of the surds, then similar or the like surds, and this box you have to write it in your notebook. This, remember this, you have to write. Afterwards, page number 29 is there. On this 29, rationalization of a surds is given, and here remember this is you have to write it in your notebook. Please go through this video again and again. Try to understand the basic concept about the surds and do the practice of solving the sum. Thank you.